Forgot. All right, I think we are live. Yeah, hi, welcome. Today we are going to continue the Zigling part 3. And as a reminder, in this series, I'm going through the Zigling tutorial to learn about the language Zig. And it is the language that is written, that's used to write the new JavaScript engine Bun. And I'm interested in it because of the way that the feature that it has. For example, some nice control flow analysis, and the promise of no macro, and able to have a very good type system. So those are the things that I'm interested in. So in the last 2 streams, we have go through the exercise all the way to quiz 4, the one that you're seeing on the screen. And in this one, we will try to continue to the exercise 35 and see how far will we go this time. And this stream will probably a little bit shorter than the previous 2 because I want to keep this stream a little bit shorter. So we'll see how far did we go today. So without further ado, let's get started. Alright, let's go. Right before that, let me get myself some music. Okay, I think we're good. Alright, exercise 35. Let's see. Alright, so remember that little mathematical virtual machine we made using unreachable statement? Well, there are 2 problems with the way you're using the using opcode. Have to remember opcode. Probably we talk about it, Yep, that's what it is. So the way to define it is just define the names. So there is increment, power, and decrement. So that's that. So the enum is a construct that you give names to numeric values. So it has to be numeric value, not string, which is okay. We are talking about a lower level language, right? So it's just that, and I think we are good. So let's take a look at the program. So we get the operations. The op is an array of op. The size is inferred, and so we have basically 6 operations over here. Right. So we start with 0 for each operation. So the first one will do the increment. So from 0 we plus 1. So it becomes from 0 to 1, 2, 3, and then power, which is 9, and then decrement. So at the end we get 7. Yep, there you go. All right, so second. Okay, so we're good. Enum2 are really a set of numbers. You can leave the number up to the compiler, or you can define it, define the value, so that's fine. Set it in. You can get the integer out with a built-in function enum2 int. Because it is strongly typed, the type of the enum is a enum, so we do need to do a cast over here to get it back to the number. Unlike in TypeScript, it's just synthetic sugar, right, basically. So with that gives us the value back. And so one interesting thing is over here you can define the type. So that is a U8. It's unsigned 8 and unsigned 32. That's an unsigned 32. Why there's no? So we can define it in hex. So RGB, well, RGB 0000FF. Just that. So it's a multi-line string. So basically this is the one. To do a multi-line string. So the value x can be, and then it will be printed out as the pattern with the pattern zero, the pattern character 0, and then a line right and width 0. It is a little bit cryptic, but probably is certain standard way likely to see. So not going to complain with about that. Right, so I think that's it. And then while I'm doing that, oh, forgot x0 greater than 6, also printed in hex. Red, blue. Why this printout doesn't print out green? Take a look again. Okay, there you go. It's a VS Code issue. All right, that's fine. So let's take a look at structs. Being able to group values together, let us return this. So basically create a struct. This is what it's about. All right, so define a point with x, y, and z. So yeah, just define it, specify the type. So we will use an enum to specify the character class. Please add a new property to this struct called health. And or just U8. Okay. Is initialized drop with 100 health. Does it provide completion? Character break. It's a enum. This is wrong. This is completely wrong. Right, that's what that is. Dot Okay, this is wrong, but that's okay. We're not complaining about that. So gain some gold. Take a punch. Okay, think that's it. Right, there you go. So just like before, well, in Sig, the way to initialize a type or initialize the struct is using this format, right? The name of the struct and then curly bracket. So in the previous exercise, we try to create a anonymous type or anonymous struct by doing it like this. So I think even if I do this, this will pass. Let's see. No, it doesn't. Cannot assign to const. Oh, these are by default set to const, unless when I will specify like this, it will be mutable to begin with. Okay, so that is a difference between the anonymous struct versus a typed struct. Is there a way to specify the struct to be a const? My guess is probably it doesn't make sense, right? Because yeah, it probably doesn't make sense because over here, from what we have learned so far, the struct, well, sorry, the const compile time variables, right? So unless we're talking about runtime immutable type, specifying a const in the struct doesn't really make sense, right? Because it's static. So that's fine, that's good. So exercise 38. That. So grouping values in struct is not merely convenient. It also allows us to treat the values as a single item when storing them, passing them, well, by reference. This exercise demonstrates how we can store struct in an array and how doing so let us print them using a loop. Okay. So still the same thing, and then create an array of size 2, undefined to begin with, and then we just specify them. Specify the first character, and so here, without adding some, well, we can do it later. We'll first add it in. So character. So class is a bot, and then gold, gold 10, health is 100, experience is 20. Okay, and then semicolon. So then, yeah, this will pass. I think yes, it does. So if I took it out, it would just run the first one, right? Oh, hold on. Because we set this to an array of 2, we define the size. Maybe it will get messed up because it's got undefined. Does it? Yes. Well, it's not really undefined. It got garbage because the memory is not initialized. If you try running a program without adding some as mentioned above, you get what appear to be garbage values. In debug mode, which is the default right repeating pattern 1010 in binary or AA in hex to all undefined location to make them easier to spot and debugging. So meaning these are all in hex. So meaning if I doing it like this, what will it print out? Let's take a look. Yeah, it's all A. All right. So that's interesting to save, to make it easier to debug. That's definitely a good thing. On just-func, right, unless we're talking about the just itself, in just-func is which is a higher level language, I don't really have to worry about this because it is defined, the behavior is defined by the underlying language that's running the interpreter. So of course, if the interpreter are writing in Rust or in C or in other things, I do have to worry about it. Actually, would it be an interesting idea to write just-func using Zig? That could be interesting. Well, and the same thing for writing the interpreter in Rust. Yeah, I think that's a good idea. So once we define the type, the syntax well enough, and wrote a interpreter in TypeScript, then the next things will be writing in Rust, which I do have in plan, and maybe also in Zig also. So anyway, next. So check this out. While full U85 what is a pointer? It is a reference to a value. Well, yes, well, not saying of course, because maybe some of you haven't worked with language that deal with pointer in the past. So it's a pointer with the reference, all that stuff is a reference to a value. In this example, bar is a reference to the memory space that currently contains the value 5. It's a pointer to the full, which contains the value 5. The type of U8 value full, given the above declaration full, the value 5, pointer unsigned 8. That this one is a really is a no, never mind. So this is a pointer to a unsigned 8. And then the reference to full, pointer at the value full, dot star is to dereference. That's the way of dereferencing in Zig. And I actually, regarding this, I like that compared to Rust, because Rust have that automatic dereferencing for convenience. But for newcomers, well, for when you get used to the language, I guess it's definitely convenient to do the automatic dereferencing. But it could be a point of confusion. Right, so I think Zig take the approach of making everything explicit, right? So I personally I like that approach. And in just-func, I'm thinking about the same, try to avoid any synthetic sugar and just try to keep the language simple. Right. So anyway, go to the main and then make num2 equal to 5. So it's the address of num1. or using num pointer. Okay, so num1 pointer dot star. There you go. Pointer lesson 2. All right, it is important to note that variable pointers. Let's go. It is important to note that variable pointers and constant pointers are different types. Yes, ref is pointer to an sign, and this is a const. You can always make a const pointer to a variable, but you cannot make a variable pointer to a const. It sounds like a logic puzzle, but it just means that once data is declared immutable, you can cause it to a mutable type. It's a safety thing. It's true. It's probably correct. Well, obviously it's correct. I'm just thinking about in contrary when I am, because when the bar is allowed to point to the full, right? The address bar, you know, if you create a pointer for it, you can point it to the a mutable type. And in a multi-threading environment, could that be a problem? Syntactically, it is okay, but semantically, it does mean that when we declare, so maybe down here we can take a look. Well, okay, it doesn't really have that example. So if we point to, let's create it. Let's create it over here. So it's a const. This I need to change it to const, so that's all. Yep, there you go. So the questions I have is, says, for example, is doing that full U8 equals to 5, right? So over here, I can say const bar, and well, no, not const bar, const pointer, let's say pointer const U8 equals to full, address of full. Okay, like that. This will build. Does it? Unused or local? And let's go into pointer. Right, to make sure that it builds first. Right, it builds. So the issue I have is that technically this is fine, right? But when we are using this variable, right, we saw that it is a const. So we do expect, at least mentally, thinking about the value it contains will not change because it's a const. However, it is actually pointing to a mutable type, and in another thread can jump in, can context switch, and change that value. Right, so we got a different result. Well, that different value that this will point to. Well, of course, it still points to the same variable. It's just the value inside that variable have changed, right? If we think about, so when we look at this const pointer. If you think about it, is a handle for us to deal with some variable, and it is a constant handle, so that it means we cannot use this handle to make change to variable. Yes, this is absolutely correct, right? But I just feel like this could lead to unexpected bug or things like that. In this regard, I do think, well, the Rust life cycle, well, the not life cycle, the variable lifetime is extraordinary. It's a really an amazing concept in handling these kind of things. So, but it is what it is. So it's just a note to myself. And again, of course, this doesn't matter in just-func. So the tricky part is that the pointer immutability, while versus cons refer to the ability to change what it points to, not the ability to change a value at that location. Log, unlog, log. So P1, both P1 and P2 points to the cons value cannot change. However, P2 can change to point to something else, and P1 cannot, right? So this can point to something else. Well, this is not the same as the thing that I was just talking about. This is just talking about the P2 is a variable itself. It's not a const itself, so that this can change, which is fine. It is what it is. I think, or at least to me, because that's how you are declaring that variable. Maybe I think this is a tutorial, so it tries to point out that even if the value is a constant, you can still point to something else, which is true, and which is what you intend because you are using var, right? But for people who doesn't understand the concept versus var, yes, this could trick them up, right? So both let's see. Both P1 and P2 points to blah blah blah. Cons 3, cons 4. Here P3 and P4 both used to change the value they point to. But P3 cannot point at anything else. Yes, that's true. What's interesting is that P3 and P6 act like P1 and P2, which the type is the same, although it points to unlock. This is what we meant. We say we can make constant reference to any value. Not just that, to the point I just made, that is you point to a value that can be changed. Right. Right. Even though the type of the pointer itself is a const unsigned 8-bit pointer. Please define pointer P so that it points to either full or bar and change the value it points to. So because it can change, so it has to be a var, right? And then it can change the value. You can do this, so it has to be a non constant pointer. So that's it. All right. So pointer exercise number 4. Now let's use pointers to do something we haven't been able to do before. Pass a value by reference. Why do we wish to find a pointer to an integer variable rather than the integer variable? Because we are allowed to change the value of the variable, which is not really a good idea. But I understand in the C world, especially when you need to deal with memory management, it is a necessity. Unfortunately, it's not like I am very fluent in C, right? I really haven't worked in C for many years. It's just recently I was have a chance to work with some C code for about a few months, right? So I get my hands wet with it again, and from what I have learned or relearned, because of the memory management, some of the things that we love, for example, do not use out param or do not modify the reference, the value inside the reference of your parameters, sometimes is a necessity, right? Because doing it otherwise is a much harder endeavor, put it this way, right? Because when you do that, then you need to somehow remember the reference of the memory that you create inside the function, and then you return it. So then you need some system to capture the fact that that memory has been created but not destroyed. So all that stuff, and that's definitely could lead to bugs, memory leaks and things like that if you're not being careful. So anyway, so back to here. So number 8 is set to 1 with many more numbers. Let's pass a reference to num. Pass a reference to num. I think what he means is pass a reference of num to a function. Yeah, I think it's off. Probably I can open a PR to help fixing this one. Well, I'll do that after the stream. So make 5, passing it in, printing it out, and now something interesting. Let's pass a reference to a specific array value and print the array. This function should take a reference and set it to 5. So x dot star should be just that. Yep, there you go. Right, that's pretty straightforward. So exercise 5. As with integer, you can pass a pointer of a struct. Of course, that is the main purpose, or that's the only way in this language, maybe I don't know. So note that you don't need to dereference a PV pointer. Oh, because it also do the referencing automatically. Oh, it also does that. Okay. So I take it back. So it is the same thing, just like in Rust. Of course, you can see the reason, right? Because for every properties, you have to do the reference. That is way too tedious. So we can write function to take pointer to struct as argument this full function modeled by struct v and call them like so. So that's okay. Take the character reference and print it, and print a link mentor character if there's one. Okay, so I need to, okay, here you can provide the default values. Okay, I need to use the question mark, the optional, to allow for null value, but I don't explain it until later. Please don't tell anyone. Okay, Well, because it can be null. What else can that be? Because it can be null. So here that is he group have a mentor, so print character. So first of all, pass that in, right? I hope, well, it will at least make this explicit. That is as expected. So note how this function's C param is a pointer. Yes, here is something you haven't seen before. When switching an enum, you don't have to write the full enum name. Understand that Richard means, it's a synthetic sugar, so you don't have to write the whole thing. So that's fine. And then just go and print it out, check an optional value and capture it. We'll explain later. So because it's optional, right? So it is using this construct to extract the mentor value and then try to print it if it has it. So okay, it does it for us, so we don't have to write it ourselves. All right, quiz 5. Elephants walking along the trails are holding hands by holding tails. From holding hands by Leonora M. Link. So what do we want to do over here? Oh, okay, so it's a linked list. So elephant A, please add elephant B. Okay. Elephant B, letter B. Okay, link the elephant so that the tail point to the next elephant. So elephant B dot tail equals to elephant C, right? And then C tail A, and then so there you go. Right, this function will reset all elephant once, starting with the first elephant and following the tail to the next elephant. If we did not mark the elephant as reset, then it will loop infinitely, of course. Okay, oh, that's it. That's the quiz. Oh, there you go. That's it. Okay. Well, so it's at minute 38. So I think let's do a summary of this stream. So we go through the exercise of the enums. So enums is based on number, so it's the basic form of enums, and you can specify predefined values like this over here. Of course, you can be just any number, not necessarily written in hex, right? And then when you use it, you can do the switch over here like this, and then from the last exercise, you see that it can be also done like this. Although I wonder, yes, it does work. So auto completion works for this case. So yeah, that's how you use it. And to extract the values, you would need to do the add something, add enum to int, I guess. Where is it? Add enum to int. I don't see the message. Yeah, here, enum to int, right, to get the value now. Actually, on that, any type. Well, because this guy is a generic type, Probably we haven't get to it. So that depends on the type, it will able to return UA, unsigned A, unsigned 16, or signed, and so on. So then we talk about struct. So basically just the regular struct type, nothing too special about it, and you can initialize, define. On the other exercise, you can define predefined values over here, right, like that. So that's fine, and then just use it. These are relatively easy. And then from here, you well, it's just an array, right? You get each character and then get the index. So that's it, nothing special. Second. Okay. So then we start talking about pointers, right? So there is you can define a pointer as variable or as constant. Is a constant pointer, a variable pointer, and then the type that it points to can be a variable or a const also, and that's how you dereference it when the type is scalar. But when it comes to struct, it have the automatic dereferencing as shown in here, I guess. Is that right? Yeah, it's shown in here, right? So it supports the referencing automatically, and besides that, not much, is pretty as expected. So I think that's it for this session. So hope you enjoyed it, hope you learned something. To be honest, for this one is a little bit basic for myself, and nothing special or surprising. And but well, that's that, right? And anyway, hopefully you find this session useful. You're able to learn something from it. And with that, we'll see you in the next one. Bye.